There is a graveyard on Mars. No headstones, no flowers, no visitors. Just the rusted silence of a planet that has been dead for billions of years. And somewhere on its surface, a machine the size of a golf cart, buried to its axles in soil. It never managed to escape. It has been there for over 15 years. It will be there for millions more. But before it stopped moving, it changed everything we thought we knew about the red planet. Today, we are telling the full story of the Spirit Rover, a machine launched on a 90-sol mission that somehow kept going for over 2,000, that stumbled into discoveries by accident, that dragged a broken wheel across an alien world and still managed to rewrite the history of Mars. This is a story about failure, resilience, and what happens when a robot refuses to give up. Let's go back to the beginning. It is January 2004. Spirit has just survived one of the most violent arrivals in the history of planetary exploration. After a 7-month cruise through interplanetary space, the spacecraft carrying Spirit slammed into Mars' atmosphere, traveling at over 19,500 kilometers per hour. It had no engines to slow itself. Instead, it relied on a heat shield, a parachute, and an extraordinary system of airbags that inflated around the lander in the final seconds, transforming it into a bouncing, tumbling ball of foam and metal. Spirit hit the ground, bounced dozens of meters into the air, hit again and again, rolling nearly a kilometer before coming to rest inside GUSEV crater, a 166-kilometer wide basin that scientists believed may once have been filled with water. The mission had a single focused objective: find geological evidence for the past presence of water on Mars. If water existed there, then Mars was not always the frozen desert it is today. And if it wasn't always a frozen desert, then at some point in its ancient past, it might have been capable of supporting life. No pressure. Spirit's science toolkit was purpose-built for this investigation. The rock abrasion tool, or RAT, could grind away the outer surface of a rock, exposing fresh material that had never been touched by the Martian atmosphere. The microscopic imager captured close-up details of rock textures and grain structure. The alpha particle X-ray spectrometer measured the elemental composition of samples, while the Mussbauer spectrometer identified specific iron-bearing minerals. And of course, a suite of cameras allowed Spirit to navigate, survey, and photograph its surroundings in stunning detail. It was an impressive payload, but within days of landing, it almost became irrelevant. On Sol 18, Spirit went silent. Not a temporary glitch, a full communications failure. The rover stopped responding to commands, sending back only fragmented, corrupted data. Back at the Jet Propulsion Laboratory in Pasadena, engineers worked around the clock to diagnose the problem. What they found was alarming. Spirit's flash memory, the storage system that holds data even when the rover powers down, had filled with so many files that the system was caught in a continuous reboot loop. Every time Spirit tried to start up, it immediately crashed and started again. The fix required sending a software patch across 142 million kilometers of space and essentially reformatting a critical piece of hardware on a robot they could not touch. It took 2 weeks, and it worked. Barely 6 weeks into its mission, Spirit had already demonstrated something important. It could be saved, and more importantly, the people operating it were not going to give up easily. With communications restored, Spirit began its real work, and the red planet began to reveal itself. The floor of GUSEV crater, it turned out, was largely covered in volcanic rock. Water may have once filled the basin, but billions of years of geological activity had buried any sedimentary evidence beneath lava flows. It was frustrating. Spirit was sitting inside what scientists had hoped was a dried lakebed, but the surface told a different story, so the team looked further. Roughly 3 kilometers to the east, a series of low hills rose above the crater floor. The Columbia Hills, named after the Space Shuttle Columbia and its crew, lost the year before Spirit launched. The hills were never part of the original plan. They were too far away, beyond what Spirit was realistically expected to reach. But with the rover performing beyond expectations, NASA decided to try. What followed was a 3-kilometer drive across terrain, littered with rocks, dunes, and loose soil, a journey that took months and pushed both the rover and its operators to their limits. But when Spirit finally began climbing into the Columbia Hills on Sol 156, it found something entirely different from the volcanic plains below. Rocks that showed clear signs of alteration by water. The hills told a story the crater floor had kept hidden. Minerals that form only in the presence of liquid water. Textures consistent with prolonged exposure to aqueous environments. The mission's central objective, find evidence of water, was already being met, and Spirit was only a fraction of the way through its life. Spirit spent the next several hundred sols exploring the Columbia Hills in methodical detail. Each stop produced new data. Each rock analysis added another piece to Mars's geological history. There was Wishstone, a finely grained volcanic rock showing signs of chemical weathering. There was Watchtower, a layered outcrop packed with information about ancient volcanic and hydrothermal processes. And there was Paso Robles, perhaps the most striking find of this period. A patch of soil Spirit's wheels accidentally churned up during a routine maneuver that turned out to contain extraordinarily high concentrations of salt and phosphorus. The discovery was not planned. Spirit had simply been driving, repositioning itself, and in doing so exposed something that would have otherwise remained buried. The salt content alone was remarkable, levels suggesting that large quantities of liquid water had once moved through that area, depositing minerals as it evaporated or froze. It was a reminder that some of the most important discoveries in science are not found by looking in the right place, but by accidentally looking in the wrong one. Meanwhile, Spirit was climbing. Husband Hill, the tallest peak in the Columbia Hills at roughly 100 meters above the crater floor, had become the next major target. The ascent was slow and energy-intensive. The Martian atmosphere was thickening with dust during this period, reducing the amount of sunlight reaching Spirit's solar panels and threatening to cut power levels below the minimum needed for safe operations. Then, on Sol 421, something remarkable happened. A Martian dust devil swept directly over the rover. These atmospheric vortices are common on Mars, columns of spinning air that can grow hundreds of meters tall and scour the surface clean as they pass. And that is exactly what this one did. In a matter of minutes, a year's worth of dust accumulation was lifted from Spirit's solar panels, and the rover's power generation jumped from roughly 60% of its original capacity back to over 90%. Nobody at JPL had scheduled that. It was the planet itself, in some small way, extending Spirit's life. On Sol 581, Spirit reached the top of Husband Hill. It paused there and did what any explorer would do after an exhausting climb. It looked around. The panoramic image Spirit captured from the summit is one of the most striking photographs ever taken on another planet. Hundreds of frames stitched together into a sweeping view that stretches to the Martian horizon in every direction. The Columbia Hills, the flat plains of GUSEV crater below, the distant ridgelines of McCool Hill and Ramon Hill catching the thin Martian light, and in the foreground, Spirit's own deck, clean, dustless, evidence of those life-saving dust devils. From the summit, Spirit also imaged both of Mars's moons, Phobos and Deimos, crossing the night sky in long photographic sequences designed to improve measurements of their orbital paths. Even at rest, the rover was working. The descent from Husband Hill would prove equally productive. On Sol 690, Spirit's instruments analyzed a rock named Comanche and found something extraordinary. Roughly 1/4 of the rock was composed of magnesium iron carbonates, a concentration approximately 10 times higher than anything previously measured on Mars. Carbonates are minerals that form in the presence of liquid water, but they are destroyed by acidic conditions. Their presence in such high concentrations indicated that at some point in Mars's history, there existed bodies of water that were neutral or even mildly alkaline, conditions far more hospitable to microbial life than the acidic environments suggested by other Martian geological records. It was a significant recalibration of the picture scientists had been building. Mars had not always been the same kind of hostile. It had been different kinds of hostile at different times, and in some of those times, something may have had a chance. At the base of the Columbia Hills, Spirit arrived at one of the most geologically interesting features of its entire mission: Home Plate, a raised, roughly circular formation of layered and eroded rock approximately 90 meters across. The structure's origins were debated, but the layering patterns and rock chemistry pointed toward explosive volcanic activity, possibly an ancient eruption that sent superheated material blasting across a wet surface, baking mud and sediment into the layered formations Spirit could now examine up close. The edges of Home Plate showed features that were difficult to explain without invoking flowing water or steam: carved surfaces, unusual mineral distributions, the kind of thing that makes geologists reach for their notebooks. But March 2006 brought a development that would change everything. One of Spirit's 6 wheels seized entirely. The right front wheel had been showing signs of increasing friction for months. Now it stopped turning completely. Engineers at JPL ran exhaustive simulations on identical hardware back on Earth, trying everything they could think of to restore function. Nothing worked. Spirit would spend the rest of its life dragging that wheel behind it, a locked metal disc carving a continuous groove through the Martian soil. And that groove would change history. In March 2007, as Spirit was navigating around the western edge of Home Plate, the dragging wheel gouged through the rust-red surface layer and exposed something startlingly bright beneath, almost white, completely unlike the surrounding terrain. It was silica, nearly pure silica, concentrated at levels that matched only 2 known geological processes: hydrothermal hot springs, where water dissolves silica in one location and deposits it elsewhere as it cools, or fumaroles, where steam and volcanic gases blast through rock, stripping away other minerals and leaving silica behind. Both environments on Earth are places where life thrives. This discovery, made entirely because a wheel had failed, because the rover kept going anyway, because the dragging mechanism happened to cut through exactly the right patch of ground, was described by scientists as the most significant find of Spirit's entire mission. If Spirit had been healthy, it would have driven straight over that patch without disturbing it. The broken wheel was not a limitation. It was an instrument. The months that followed were quieter, but not without purpose. Spirit continued to circle Home Plate, documenting its geology, capturing atmospheric data, sending back images that would take years for scientists to fully analyze. In June 2007, another dust cleaning event pushed power generation back above 600 watt-hours. The machine was still alive, but the Martian environment is patient in a way that machines are not. By 2009, 2 of Spirit's 6 wheels were no longer functioning. Dust storms had returned, coating the solar panels and cutting available energy. Memory anomalies were beginning to appear, signs of aging components under sustained stress. The rover's power generation was hovering dangerously close to the minimum required to keep its internal heaters running. Without heat, the electronic components would fail. On Sol 1892, Spirit drove into a patch of soil it could not escape. The location was named Troy. Beneath the deceptive rust-colored surface crust was a deep layer of extremely fine, loose material: jarosite, an iron sulfate mineral with almost no cohesion. Spirit's wheels spun without gaining traction. Every attempt to move dug the rover deeper. For months, engineers on Earth constructed a replica of the trap in a JPL testing facility and tried combination after combination of wheel movements, driving angles, and extrication sequences. None of them freed Spirit. On Sol 2155, NASA formally reclassified Spirit as a stationary research platform. It was not an ending. Not yet. From its fixed position at Troy, Spirit continued to study the Martian atmosphere, examine the soil beneath its belly, and build up the long-term meteorological record that only a stationary instrument can provide. Its arms still functioned well. Its cameras still worked. It was no longer going anywhere, but it had not stopped doing science. The final winter came in the southern Martian autumn of 2010. Temperatures dropped. Power generation fell. On Sol 2196, Spirit's available energy dropped back to the critical threshold of 150 watt-hours. the minimum required to maintain the heater systems that kept its electronics alive. Communication attempts became less frequent. The rover needed every watt it could collect just to survive the night. Sometime around Sol 2208, Spirit experienced a low-power fault. The last confirmed communication from Spirit was received on March 22, 2010. After that, silence. Spirit traveled 7.73 kilometers across the surface of Mars. It operated for 2,088 Martian sols, more than 23 times its intended mission duration. It transmitted over 128,000 images. It found evidence of ancient water, ancient volcanic activity, ancient hydrothermal environments that, on Earth, would be called cradles of life. It found all of this because it kept going long after it was expected to stop, because the people running it refused to give up, because a broken wheel turned out to be a gift. The Perseverance rover, currently operating in Jezero crater, carries with it a small piece of tribute to the missions that came before, a family portrait of the Mars vehicles, Spirit among them. And somewhere on the slope just west of home plate, in the long Martian night, the rover that refused to quit is still out there, frozen, silent, exactly where it fell. But the data it collected is still being studied. The maps it made are still being used. The questions it raised are still being answered. Some missions end, others just become the foundation for everything that comes next.